Hi everyone, Mr. King here. We're going to go over the fourth problem on a recent worksheet. I think I called it Modified AP Motion Analysis or Particle Motion Analysis Problems. This particular problem was the final one on that sheet, and it's actually from the 1990 AP Calculus BC exam, but that was 25 years ago. A problem like this could easily show up on the 2015 AB exam, or something this flavor. We only need differentiation and analytical work to do this problem. We don't need to know some things that we will have not learned here in the first semester in AP Calculus yet, involving integration, and that allows us to do other things when it comes to analyzing particle motion. Anyway, in this problem, the first thing we're going to get after is finding the velocity of the particle for any time greater than or equal to 0. Now our function, our position function, is a quartic because it's a cubic times a linear function, and so that's degree 4. We should expect a degree 3 cubic function for the velocity. So let's see what we're going to get. Now, fortunately, we know the chain rule now. Without the chain rule, we'd be forced to expand t minus 1 cubed and then double distribute with the 2t minus 3. Kind of a pain in the neck. Nonetheless, that would work if we had to go that route. Now this is a no calculator problem, so if we can find the velocity in factored form, it's actually going to be easier to solve. So the position is in factored form. So here we go. So a of t, the velocity, is equal to x prime of t. And we're going to use the product rule here, and we'll need the chain rule along the way. So if we take the derivative of the first, the t minus 1 cubed, we're going to get 3 times t minus 1 squared times 2t minus 3 plus t minus 1 cubed times 2. And now we're going to do a little bit of magical work, you might say. We're going to be rewriting this in a much more friendly form because it definitely doesn't look too friendly. But notice something. We step back for a moment, metaphorically, and we look at this. We see that we have t minus 1 squared and we have t minus 1 cubed. Think GCF. So we're going to rewrite this right now. We're going to rewrite it as follows. We're going to bring a t minus 1 squared out front. That's going to leave the 3 times the 2t minus 3, and it's going to leave us with that plus 2. We basically distributed out the t minus 1 squared. And now we're going to clean up what we've got here. And actually, I've just made a mistake, so I'm going to back it up right now. This is the kind of thing you need to be careful of, and if you find that you make silly mistakes, be on the lookout. I caught this one. Here it is. We took out a t minus 1 squared, but this was t minus 1 cubed, so I left out this part of that distribution. There's a t minus 1 right there. Now, I'll be honest, I knew that that was missing, that something was wrong, because I've done this problem before and it didn't look right. So anyway, nonetheless, be careful. So we're going to simplify all of this right now. Out front, things stay the same, t minus 1 squared. But 3 times 2t is 6t, and then this 2 times t is 2t. That's an 8t. And then 3 times negative 3 is negative 9, and 2 times negative 1 is negative 2, and negative 9 and negative 2 is negative 11. And this is the velocity function that we want. It's in factored form, and it's easier to work with. You'll see why in just a moment. In part B, we're asked to find values of t where the velocity of the particle is less than 0. So we want to know when v is less than 0. Well, to do this, notice something about the velocity. This part of the velocity function is always non-negative, t minus 1 squared. Not so for the 8t minus 11. It has a sign chart that looks like this. 11/8 is where 8t minus 11 is 0, but that's a linear function. It's negative to the left of that, and it's positive to the right. And so the velocity sign, that is going to be determined by the time being less than 11/8 and greater than or equal to 0. And possibly one other issue. What's true about the velocity at t equals 1? So these are times. Here's velocity. A little sign chart to help ourselves out. 11/8 is over here. You know the velocity is positive here, negative here. We can put 0 over here. At t equals 1, notice that t minus 1 squared is 0. So we've got a few places where the velocity is 0. Velocity is 0 right here and right here. Positive to the right of 11/8. It's between 1 and 11/8. The velocity is negative. And then what about the sign of the velocity when it's between 0 and 1? Well, clearly the times between 0 and 1 falls in this area over here. So the velocity is also going to be negative between 0 and 1. So we can now say that the velocity is less than 0 when t is less than or equal to 11/8 but not t equals 1. Another way to say that would be to say as follows: but t not equal to 1, like that. Now let's take a moment to think about this and see if we got all of our inequalities right. I'm thinking that maybe this one may not be right. Let's think about that. Well, what do you guys think? Did you conclude, as I just did, that this is in fact correct? Remember, we were looking for when the velocity was less than 0, the times going from time greater than or equal to 0. And there is no 0 of the velocity at t equals 0, hence that less than or equal to right there is correct. 11/8, however, there is a 0 of the velocity, as we discovered. So this answer right here is a good one. Let's move on to part C. So in part C, we're asked to find the value of the time when the particle is moving to the left, and that means the velocity will be negative, and when the acceleration is 0. So we're going to need to find the acceleration function and find out what times make it 0. Well, the acceleration, oops, let's get this pen back. The acceleration is equal to the derivative of the velocity. And our velocity, let's see, our velocity was t minus 1 squared times 8t minus 11. And so if we take the derivative, let's see what we're going to get. We're going to need a 2 times t minus 1 times 8t minus 11. And then we're going to add to that 8 times t minus 1 squared. So this time, as in the previous time when we found the velocity, we see that t minus 1 is again a common factor. So for a second time, I'm going to factor out this t minus 1, and that's going to leave us with a 2 times 8t minus 11 plus 8 times t minus 1, like that. And now we're going to clean up inside. So the t minus 1 is out front, and inside we've got 16t minus 22 plus 8t minus 8, like that. And then combining terms inside, we've got 24t minus 30. And then factoring a 6 from these, we get 6 times t minus 1 times 4t minus 5. And this is our acceleration function. Now the reason I did this extra factoring here and brought this 6 out is it simplified this second linear factor. It's not essential, but it's kind of the simplest factored form of the acceleration function. We can now set the acceleration equal to 0 and very quickly find out that the times that set the acceleration equal to 0 are in fact t equals 1 and t equals 5/4. Now, the question that we want to answer is, when is the particle moving to the left? In other words, when is the velocity negative? Well, at t equals 1, we know that the velocity is 0. But at t equals 5/4, that puts us up above here in this region, and the velocity is negative there. So we can say that the velocity at 5/4 is less than 0. And we've answered the question. I hope this problem solution has been helpful to you guys. As always, King Calc over and out.